Okay, so let's take a look at a dimensional analysis problem involving density. Now, I think many of you might be tempted to solve this problem as follows. You know that density is mass divided by volume. You know the density, you know the volume. Therefore, simple multiplication can give the mass. And that would work. There are two problems with this approach. One is it really doesn't work when we have much more complicated problems. And the second is that this presentation is kind of cumbersome. It's hard for your reader to understand what's going on. So I would really strongly encourage you to use dimensional analysis. One, there's no unit here. As well, which is annoying. But I would strongly encourage you to use dimensional analysis because it's easier for your reader and it's going to greatly simplify the problem over the long haul. So I would posit that this is the old school approach that we will no longer use. So we're going to use dimensional analysis instead. We know we have 6.6 centimeters cubed of iron. We want ultimately to get to grams, so let's use dimensional analysis. So we ultimately want to put centimeters in the denominator to cancel out the centimeters cubed, in the denominator to cancel out the centimeters cubed, and we know a numerical relationship between the two, namely it's the density. Now there's an implicit 1 in the density. So you should understand that there are 7.86 grams for every 1 centimeter cubed. So I'm going to plug those in like so to get my final answer as 51.86 grams. Now note that that isn't ultimately my final answer because I need to pay attention to significant figures. So let's apply the rule. We know that there are two significant figures in our starting value, 6.6 centimeters cubed. So we're going to report this as 52 grams. So that should be our answer. Notice that this is cleaner, it's easier to read, and it's going to help us as we have more calculations pieced together later on in the term.